In this lecture, we're going to be going over the basic science and principles of light, so you can have a deeper understanding of how light works when we're painting our pictures. It'll help us to make more informed decisions about our lighting situations in our paintings, and it'll add another level of realism. So here we just have a simple, basic lit sphere, okay? Now, light travels in photons, little tiny light particles, okay? And we need to keep that in mind, that when these things are traveling, they travel in a straight line, okay? So one way to be able to tell where your shadows are supposed to lie is by looking at where your light is coming from. So if we have light coming from up here, then all of the light that's going to be coming down is going to be coming down in straight lines and hitting this ball, okay? Now, in this situation, we're assuming that the light source is something like the sun. If it was a spotlight and it was much closer, say the light source was actually right here, then all of the beams of light would be coming off like this and hitting it. But for this scenario that I've drawn, the light is far away, okay? Because if this was the case, then the shadow would actually come all the way out here like this, because no light particles can hit it that far. Okay, so imagine though that the light source is far away like the sun. The light's going to be coming down in these straight lines in these photons and bouncing off the ball, which is why this part is in light and this part is in shadow. Okay, and you can see that the shadow of the ball lines up with where the light particles are hitting the ground. Light bounces, okay? Photons bounce off of things. So every time a photon bounces off of a surface, it typically loses about 90% of its power or energy, meaning the light will decrease. So if we imagine the light coming down and bouncing off, it's going to be bouncing around and bouncing on the underside of this ball, which is going to cause there to be reflected light, like this, okay? And that's something we really need to keep in mind. Even in a setting where, say you're indoors, the painting is indoors and there's no light on, but maybe there's an open window, there's no sun directly shining in that window. However, there is a lot of reflected light that's bouncing around. It's bouncing off the walls, it's bouncing off your skin, and that's something that we need to keep in mind. And we're going to cover all these different sort of lighting scenarios in the future, but really quick, we're just going to go over a brief scientific understanding of light. So these photons are bouncing around. Now, what happens if those photons are going through a more diffused light source? So let's turn this off really quick, and turn this off, and we'll bring this on. So imagine that it's a cloudy day. Okay, these light beams are shining through the clouds from the sun, but when they get into the clouds, they become diffused, which means that they're all broken up and they get shot in different directions instead of continuing to go straight. And what that does is it makes it so that there's a lot softer of a lighting scheme. You can see that the shadow is a lot softer because more light is able to come down here and get into these crevices and bounce around than as before. Right? We have light that can reach all the way down from here instead of having one central light source where light can only reach here. Okay? So depending on how direct your light is as compared to how diffuse it is going to determine how hard or soft your shadows are, as well as how warm or cool your light will be. So keep that in mind. A spotlight type setting like the sun is going to be straight beams of light and you'll be able to have really hard, crisp shadows. And a diffuse setting, such as an overcast sky or a light diffuser that you'd have for a movie set, it's going to be a lot smoother, right? And a lot less heavy shadows, okay? And then one more thing I want to cover, so we have a basic understanding of before we really jump in, is understanding how color works. So light is... A white light has all the different colors of the spectrum in it, from red to violet, okay? And when these are coming down from the sun or whatever the light source is and hitting objects, depending on that makeup of the object, certain colors from that light will be absorbed and other colors will be reflected. So if it's shining at this red ball, all of these different colors are coming down in the form of white light, okay? And the red is bouncing off, and that's what's hitting our eyes and telling us that ball is red, okay? Because of the makeup of this ball, all of the other colors are being absorbed except for red, and perhaps a little bit of orange, maybe a little bit of blues. Like, there's a little bit of variation. Most things aren't pure red or pure blue, but they have little tiny traces of each of these colors, but for the most part, all of these colors except for red are being absorbed. The light is being absorbed and transferred into energy, into heat, right? Which is why when things are black, the reason they get really hot in the sun is because they're absorbing all of the light, which is why they look so black. There's not anything reflecting back at us to tell us what color it is. And since it's all being absorbed, it's getting transferred into energy and making it hot. It's the opposite with something that's white. When light is hitting something that's white, all of the colors in the spectrum are bouncing off into our eyes and telling us that it's white, and therefore it doesn't get very hot. So with this red object, only the red is bouncing off into our eyes and telling us that it's red. That's the only type of light that's reaching all the way to our eyes, while the rest of the colors, orange through violet, are being absorbed and transferred into energy, into the ball. Okay? So keep that in mind. And these sort of dynamics change with the way you color your light. And that's something that we'll cover later. It gets pretty complex, but I just want you to keep these things in mind. Okay, as we progress throughout this course and we get into more depth in some of these topics and understand how this is going to affect our paintings, keep in mind that light are particles and that they travel in straight lines. Okay, and if you can keep that in mind, it's really going to help you understand from a three-dimensional point of view how the light should be affecting your subject, especially if you're painting out of your head. So I will see you guys in the next one. Bye.